Let's see how Java actually works internally. Understanding JVM, JRE, JDK, and execution flow. Many developers write Java code daily, but they don't know what happens behind the screen when we run a Java application. Today we will understand the complete journey from Java source code to machine execution. What happens when you run Java code? It's Java class, its main method, and we are printing hello Java. Let's see flow. Java code, it goes to compiler. After that, it generates bytecode. Then JVM converts it to machine code. After that, we will get output. Let's see explanation. When we write Java code, the computer cannot directly understand this code. The Java compiler converts our human readable code into bytecode. This bytecode is then executed by JVM. The JVM converts it into machine instructions that the operating system understands. Why learn Java internal? Understanding internals helps write optimized code, debug issues, improve performance, and prepare for interviews. Explanation. As a Java developer, knowing internal working helps you write better application. For example, understanding memory management helps prevent memory issues. Understanding JVM helps in performance tuning of Spring Boot application. Let's see Java architecture overview. Java platform, JDK, JRE, and JVM. Explanation. Java architecture has three important components. JDK is for developer. JRE provides the environment to run application. JVM is the engine that actually executed Java bytecode. Let's see JDK versus JRE versus JVM. Explanation. Think of JDK as a complete package. It contains JRE and development tools. JRE contains JVM and libraries required to run application. JVM is responsible for executing the program. Example, developer needs JDK, user running an application needs JRE. Let's see Java execution flow. We have hello.java file. Compiler converts it .class file, hello.class file. After that, JVM converts it machine code. After that, we will get output. Explanation. First, we create a Java file. The compiler command javac converts into a class file. The class file contains bytecode. JVM loads the bytecode and executes it. Java compiler, source code, compiler, bytecode. Explanation. The Java compiler checks our program. It checks syntax error, type error, and code structure. If everything is correct, it generates a bytecode. Example, hello Java to class file, hello.class. What is bytecode? It's a intermediate code. It's a platform independent executed by JVM. Let's say explanation. Write once and run anywhere. The same .class file can run on Windows, Linux, or Mac. Only JVM changes according to the operating system. Let's say architecture. JVM, class loader, runtime memory, execution engine, and native interface. JVM has multiple internal components. Class loader loads classes, memory stores data, execution engine runs instructions. Native interface allows Java to communicate with the native libraries. Class loader, loading, linking, and it works for initialization. Explanation. When we run a Java program, JVM does not load everything immediately. Class loader loads required classes into memory. It performs three steps: loading, find the class file, linking, prepare memory, and initialization, execute static code. Let's see JVM memory area. We have heap area, stack, method area, PC register, and native stack. Explanation. JVM creates different memory areas. Each area has a specific responsibility. For example, objects are stored in heap while method execution happen in stack. Heap memory stores objects instance variable. Example, we are creating an object of user. Explanation. When we create an object using new keyword, it goes into heap memory. Heap is shared between all threads. Garbage collector manages this memory. Let's see stack memory. It stores local variable, method call, and references. Explanation. Every method execution creates a stack frame. Local variable are stored here. When the method finishes, the stack memory is automatically removed. Method area. It stores class information, static variable, and methods. Explanation. When JVM loads a class metadata is stored in method area. Static variable also belong here because they are associated with the class. Let's see execution engine, interpreter, and JIT compiler. Explanation. Execution engine is responsible for running bytecode. Interpreter executes instructions one by one. JIT compiler improves performance by converting frequency used code into native machine code. Interpreter versus JIT. Interpreter works line by line. JIT optimized machine code. Explanation. Interpreter is slower because it translates every time. JIT remembers frequently executed code and compiles it. This makes Java application faster. Let's see garbage collector. It automatically memory management. Example, there we have created an object of user class, and in the reference of user we are setting null forcefully. Explanation. Java automatically removes unused object when an object has no reference. Garbage collector identifies it and frees memory. Let's see complete Java internal flow. Java code, compiler, then bytecode, then class loader, memory, execution engine, and then machine code. Explanation. This is the complete life cycle of a Java program. Every Java application follows this flow internally. Let's see Spring Boot real example. Application.java, Maven build, it converts a class file with the help of JVM and Tomcat. We run application. Even Spring Boot application works on the same JVM. Your Spring Boot is compiled into bytecode and executed by JVM. The embedded Tomcat server also runs inside JVM. Let's see interview questions. Why Java is platform independent? Heap versus stack. How JVM executes code? What is JIT? How GC, that means garbage collection, works? Let's see explanation. These concepts are frequently asked in Java interviews. Understanding JVM gives you confidence to answer internal working questions. Okay. By the way, we have to practice all these in interview question for to get a good job. Okay. Thank you. Subscribe for Java, Spring Boot, backend development, and system design. And I'm going to create many more other interview related questions and explore Java, Spring Boot, microservices, and going to explore databases also. Thank you.